Now let's talk a little bit about it. As you can see, you guys can see my pointer. Let me know. I think so. So disc brakes create their braking power by forcing flat friction pads, those are the brake pads, against the sides of a rotating disc. That's the rotor. You could call it the disc, but we really pretty much call it the rotor. And so they're disc brakes. The disc is also called the brake rotor or rotor, and it's attached to the hub. So that's one thing that you need to keep in mind is the rotor is sitting on the hub. And so a defect in the hub would therefore possibly cause a change on the rotor, something that'll come into play a little bit later. And so here's pretty much a comparison. If it's disc brakes, we're going to press on the pedal. It's going to squeeze those pads, as you can see. It uses a lot more force on disc brakes. We can squeeze disc brakes a lot more, with a lot more force than we expand shoes in a drum. So this is like kind of lower pressure, and it's not going to strain the metal as much. Whereas disc, the rotor is going to get squeezed really hard, and there's going to be some deflection, which is like you could actually kind of deform the metal. You could bend the metal temporarily, but the thing is, we make the disc very strong. So the rotors are going to be heavy and they're going to be beefy, and they need to be. Whereas the drum can be sometimes a little bit thinner because we're not going to actually be applying as much force to those. So just for your understanding. Now, I want to make a point about safety. When you're working on disc brakes, you need to be understanding there could be different components under pressure. You also have to know what to disassemble and what not to disassemble. So to give you an example, we had a student. You guys are young and early in your path with me, but we had a student and he turned out really good, but he made this big boo-boo in brakes. He came off electrical, and you diagnose a lot of stuff, but you don't actually really work with a lot of nuts and bolts. So he went to take the calipers off of one of the Tacomas, number 46, in fact, and he couldn't tell exactly which bolts need to be loosened. So he found a bolt and he loosened it. And unfortunately, that bolt was one of the bolts that holds the fixed caliper housing together. So the second he loosened that bolt, brake fluid started leaking. He kind of treated it like it was a person. If you see a person bleeding out, you need to stop the bleeding. So that's what he did. He stopped the brake fluid from bleeding by just boom. He just ran in the bolts really quick, but then it was leaking. We ended up having to rebuild that caliper. So he didn't know exactly. I saw in the chat, yeah, if he was following the service manual, he'd have saved himself some trouble. Possibly he even just could have slowed down and considered it, and he would have figured out the problem. It was with Rigo's group, so Rigo did tell you the story. It's true. Now 70% of the time, 100% of my stories are true. All right, do the math. So no big deal. We fixed it, but that was just he didn't know what bolt to actually loosen, so he messed that up. Now another one. Consider whether the vehicle's been operated prior to disassembly. But I'll tell you like what that really means. If you jump on a brake job and the car was just driven, it's going to be hot. So you got to find a way to tell if it's hot. The way you should put your hand near the part and see if it feels warm. The problem is, to be really honest with you, I don't have a whole lot of feeling. I'm very insensitive on my hands over all the years. So sometimes I'll touch something and like by the time I know it's hot, it's already kind of messed my skin up. So I learned a new trick. It's kind of nasty. The spit test. If you spit on that rotor and it crackles and boils, don't touch it. All right. Don't touch it. All right. And then additional safety, because we've added, maybe hybrid, mainly hybrid and EV, but if it's hybrid, you really have to refer to service information because the way that hybrid brake systems operate could be different. For example, the Prius. You press the brake pedal on the Prius, it doesn't even build brake pressure. So it's totally different the way we work on those. One of the best practices would be remove the key, keep it far enough away. That way the vehicle can't be unintentionally turned on. So like when you power up a Prius, sometimes you'll hear the and that's actually, think about it, that's the ABS brake pump running, or really because that has the electronic booster, it's all the same thing. We're talking about the electric motor that builds pressure. So if the car powers up and you have a caliper hose disconnected, you may very well start shooting brake fluid all over the place at very high pressure.
Yeah.
So experience that.
So to add to that, when Aiden and I worked on that 2012 Prius, one of the ways Toyota said to disable it is to disconnect the brake fluid level sensor, because they're also turned to pump the ABS pump whenever you open the driver door. And we
Exactly.
verified that with it disconnected, it did not continue to cycle the pump.
Cool. So that was one thing I wanted to tell you that I've seen. You got to also consider what I added down here was, for example, they'll use electronic parking brake, or they'll use, like in the case of the Prius, they can actually apply the brakes when you open the door. And, the way that park operates on a hybrid is a bit different. They can have parking poles and they're usually engaged electronically, but on a hybrid and even just general modern vehicles, they'll brake themselves. They'll put themselves in park and they'll apply the brakes themselves, sometimes with as simple as the opening the door. So we had one. Our general class was working, I believe actually it was a Prius, in fact, and they had the drums off of an older Prius, and they went to get ready to do something like bleed it, and they opened the door and it actually tried to engage the brakes and it blew the wheel cylinders out because there was no drums on to stop the shoes from expanding. So they were just totally like you never covered that in class. And so, we've had to change our curriculum to match the newer vehicles. So if it's your typical basic car and it's a little bit older, you could probably do the brakes without referencing. But if it's something newer, if it's something hybrid, if it's something EV, you're really going to need to reference it. And so Mitchell gave some really good input there. I actually don't recall that. I may have never even known that. So that was pretty good. Sometimes you learn from me and sometimes I learn from you. So good input. And you knew that because that was in TIS or service information generically. So very nice. And that can be for non-hybrids now, by the way. So just want to reiterate. Now we continue. So there's some advantages and some disadvantages. Main advantages, disc brakes can generate and transfer great amounts of heat to the atmosphere. So it's not because we're trying to heat the atmosphere for global warming, I mean climate change. It's more, if we can generate more heat and dump it to the atmosphere, that means we're basically pulling more kinetic energy. Translation, it can stop the car faster. That's what it is. It can stop the car with heavier car, faster car. It's just more effective. The disc brakes operate at peak performance, like basically immediately. So the second you start to brake, they make a lot of heat, boom, they're up to temperature, ready to roll. Also, they're self-adjusting, so they don't need periodic maintenance like adjustments. And they also don't need a self-adjusting like mechanism lever like we have on drums next week. And disc brakes are in most cases easier to service than drums. And I would agree with that. And I'm going to guarantee you by next week, you're going to agree with that as well. But there are some disadvantages too. They are much more prone to making noise. So this is a big topic of discussion. Customers don't want to hear brake noise. And yet you read it from the textbook. This is not my slide. This slide is the textbook slide. Disc brakes are much more prone to making noise. Sorry. So we're constantly going to be fighting a bit of a battle here. The brakes are more prone to making noise. So that means we're going to do some things that we'll discuss a little bit later, like some anti-chatter, anti-rattle, all sorts of noise reduction aspects, but we're still fighting an uphill battle. Rotors also warp more easily than those in drum brake systems. So I think mainly because they're on the front, they're doing most of the work, but we do get warped rotors with some regularity, actually. And then the disc brake needs higher clamping forces. So back in the day, if you had a 1968 Chevy C10 truck, like the one I had, but I didn't have the brains or the money to really see it through, so I ended up selling it at a loss. But if you had something like that, they actually had literally just a master cylinder, no booster at all. They didn't really need a booster. It was drum front and drum rear, and the drums didn't require a lot of force. And additionally, the drums also have some other designs where they're like self-energizing. They can even further reduce the amount of energy required to apply them. But disc brakes, no, you got to stomp that pedal. You got to push so hard on that pedal, you probably can't push hard enough on that pedal. So therefore, bingo, there you go. You got a brake booster now. So it's fine, but that's partially why it's there. All right, so as we continue, here's your disc brake. Primary components, as you can see, we'll start right here. The steering knuckle, that's basically a suspension part that connects the lower ball joint to the upper ball joint. Or if it's like let's say a Camry, that's going to connect the lower ball joint to the strut. So the knuckle is like the big housing over here. It connects a lot of stuff. The caliper is generally going to bolt to the knuckle, or at minimum, the caliper bracket is going to bolt to the knuckle, right? So the knuckle holds a whole bunch of stuff. And then we've also got the brake pads, as you can see through the inspection hole on the caliper, and then the rotor you can see in between there. And then you can see the fluid inlet. That's where the hose would go. That one is most likely going to be a banjo fitting, ding, 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 like that, except no music. All right. And then if you just remember the rotor, rotational part, that's the rotational part. They're durable, resistant to damage, and they need to be because they do a lot of work. They need to get really hot. Caliper straddles the rotor and houses the disc brake pads, and one or more activating pistons. It's coming back to that one. Uses hydraulic pressure to apply the pads. So the caliper squeezes, the rotor spins. The caliper squeezes actually not directly though. It's going to use the brake pads. So the brake pads are located inside the caliper or sometimes a bracket. And so that's what we're actually dragging across the surface. Pretty basic. Now with rotors, just generally, we're going to cover this one more time, but disc brake rotors can be solid or vented. So this would be vented, or the top would be solid and the bottom would be a ventilated type. And that's because they're hollow and they have actually fins for air to cool. So we'll continue. Now let's just chat about the overall operation, shall we? Customer presses the brake pedal. Brake pedal pushes the brake pedal push rod. And now you know all about this booster. So the booster is going to do its magic. The diaphragm is going to ultimately push on the brake booster push rod, which is going to push on the primary piston, which is going to push fluid, which is going to push the secondary piston. And right there, that master cylinder, assuming everything's working right, is going to move the fluid out. When the fluid is moved out, now we'll zoom out to up here. Fluid is going to go to the left front caliper, to the right front caliper, to the left rear caliper, to the right rear caliper. And this is on a four-wheel disc system. It's disc brakes front and rear. And basically, each of those disc brakes is going to do their thing. The caliper is going to squeeze one way or another and squeeze the rotor and slow it down. The reason it's important to understand this is, sometimes we do have an issue. Like if you push the brake pedal and the vehicle pulls hard to the right, that could seem to be an alignment issue. But it's only when you press the brake pedal. That's when it pulls driving, not pressing the brake pedal, that's more like an alignment pull or tire pull. When it's fine until you hit the brakes and then it pulls, we call that a brake pull. So if you have a brake pull, that's when we might have to take a little bit of a step back to the hydraulics aspect. If you're stepping on the brakes, and let's just simplify this, we won't even talk about how it's brake force distribution or how it's split. You should get equal force on the right front, equal force on the left front. But if you get, let's say, not enough force on the right front, but a lot of force on the left front, picture yourself having handlebars here. The right front didn't get a lot of pressure. It's not going to slow down. The left front did get a lot of pressure. It's going to slow down. If I look at my hands and I do this, I'm turning a bicycle to the left. So that car is going to pull to the left. Now, Marty put in the chat, it could be a bad bushing, but that gets a little bit more advanced in suspension. So for now, we're just going to discuss, the brake pull. Essentially, I would at least probably begin with just looking at what is different side to side. So Nellie's question, would it make a noise? Well, let's just say one of these rotors was grooved, and then I looked at the pads and I found they're metal to metal. Maybe my left one is metal to metal, and now I'm dragging metal across metal and it's making a lot of friction. That would make a ton of noise, absolutely. But if I didn't see anything, with the friction surface of the pads or the rotors, if they look kind of normal, I might actually have to consider, what if there's air in this brake line? There's air in this brake line, that's going to drop the pressure, right? Because the air is kind of spongy. The air is like mushy, and fluid is firm. You can't compress a liquid. It's incompressible, right? And so if you think about, all the possibilities, there could be several that could cause that brake pull. We could actually measure the clamping force right here. We could actually, if we had to, we could measure the hydraulic pressure. So there's quite a bit to that, but at least understanding the brake fluid goes through, from the master cylinder to the line to the caliper. Now, if we had a leaking caliper piston, how do you think you would find that? Because that could cause maybe a little bit of a pull. A leaking caliper piston would be external. So that, as we get more into the disc brakes, you have to remember, master cylinders can leak. Well, they can technically leak externally, but a lot of times they'll leak just internally. So you would not know if the seals are bad in the master cylinder. If they're bad in the caliper, the fluid leaks out. Like you can see that on the ground or on the wheel or something behind the boot. All right, so we'll continue. Now, if you look, here's two different types of rotors. But basically this is just describing what I described. That's how the calipers are applied. They're going to squeeze the rotors. This would be old school. This is a hubbed rotor. This rotor includes the studs because it's got a hub built into it, and the hub always holds the studs. Unless it's a German car, in which case it's just threaded holes and you use lug bolts. I just can't compute. So this would be the hubbed style, would actually have a wheel bearing that would have to go with it. If you needed to work on hubbed rotors, you're talking about having to pop out a dust cap, having to pull a cotter pin, having to loosen the nut, and then having to pull the outer bearing and then pull the whole rotor off. These are a little bit more involved, and there's some mistakes you can make, and we'll make a video on those. And then this is hubless. This is everything you're going to see every day. It's just a rotor that sits on the hub. So if you're replacing this rotor, the hub stays. You just smack it off there and there you go, ready to go. Right, and then here's an example of how the caliper can mount. If you look carefully, this part in here, where that CV axle is, it's black with some rust. That's all the knuckle. So in this case, the caliper bolts to this part, which is a bracket. So if I were to work on these, I would go ahead and I'd remove those upper and lower bolts. On a Toyota, those are probably gonna be 14s, right? And then the caliper alone would come off and the brake pads would stay right there in the bracket. And then I could actually, take the pads out, like what some of the people were doing on the brake lathe, just pop the pads out. Or if you really needed to pull a bracket because you're gonna replace the rotor or something, then the rotor, the bracket bolts are in here, very different torque specs. Like these might be 20 something and these might be 80 something. Okay. If you do 80 something on this one out here, you break it in half. And if you do 20 on this bracket to knuckle bolt, that falls out. And you know where this ends. Okay. And so, yeah, you gotta be a little bit careful. And then sometimes some vehicles may actually use rotors that are inboard. So not out here by the wheel, but like in maybe by the differential or the transaxle. It's kind of wild. Like Hummer does that. Hummer H1, not mine. And then this is a different type of an example. And so now there's two different types. So fixed calipers, we're going to come back to that, and sliding calipers, we're going to come back to that. But just so you know, there are different types. Both of them are going to clamp the rotors against the pads against the rotor. They do the same job, but they do it a little differently. Okay, so here's like, you know, an example of how it's going to squeeze. So if you look at the caliper right here, we're going to send fluid from the master cylinder down, and it's going to enter the caliper and it's going to push the piston because we pressurized it. The piston has a seal. See that? That's the black dots. That's like an O-ring. Caliper piston seal. And then it's going to push the pad, and then it's kind of weird. This is a sliding design. We're going to come right back to that. But essentially, when the fluid pushes the piston pushes the pads, and that squeezes and slows it down. All right, cool. So that's the overall. Now, here's more of an example for that floating caliper. There's pads on both sides, right? So there's a pad over here, and there's a pad over here. And there's a rotor in the middle, but there's only a piston on one side, and it's always the inboard side away from the wheel. So if you think about that, hydraulic force is generated on one side of the rotor, but equal braking forces applied to both. It doesn't make any sense. And it's kind of hard to explain with words, but I'll do my best. Pressurized fluid comes in here, pushes the piston. The piston is going to move to the right. The piston is pushing the pad. When the pad hits the rotor, you can see it's kind of like your fist. If you push your fist up against your hand, it almost starts to like kind of push back, you know, in a way, but that's because your arm can move. So when this pad hits, it's actually going to try to lift the caliper to the left. When that does, it's going to squeeze the outboard pad in. So it basically, because that caliper can move so freely, it's going to distribute the braking responsibilities 50% on the inboard pad and 50% of the outboard pad. But I said if it can move freely. So like, let's look at this next one. This is pretty much what you can see. It's literally pushing right here, boom, and that's going to pull the housing to the right. So the piston pushes to the left, which pulls the housing to the right. See the arrows? Boom. Each pad should be equally sharing. If for some reason you worked on a car and you had let's say a thick outer pad and a thin inner pad, that would tell me that the caliper is not sharing 50-50 responsibilities, right? It could be the other way around as well. In fact, I see it more commonly, a thick inner pad and a thin outer pad, but I've seen them both ways. I would take a look at these. So these are the guide pins. When we apply the brakes, we're counting on this caliper being able to slide nicely and freely on those guide pins. So if you don't know how to do a proper brake job and you're just thinking that your whole job is to just like get some pads on there. In fact, you could even go a step further and do new pads and new rotors. But if you have, let's say, rusty guide pins, your brakes are going to wear prematurely. You may get uneven brake pad wear, right? Those would all be issues. I'll tell you something that's maybe even a little bit more embarrassing. When our cars needed brakes, you know, when I was growing up, I hadn't gone to school. I hadn't received any formal training. I didn't know any better. My dad would tell me, yeah, we're going to do the brakes on that. And he'd have me use anti-seize. You guys ever seen that? Anti-seize is like never seize or something. Copper coat, you know, they have different names. but it's petroleum based and it has a little bit of metal in there. It seemed fine with me. I don't know. When you applied that anti-seize, they would move nice and smooth. But our brakes never sounded as good and they never lasted as long. And so when I started taking classes, I started learning a little bit from someone whose job it is to find the truth. That's my job, by the way. There's a lot of information out there, and you don't even really need me to get the information. But if you don't know any better, how do you know what information is good or bad? See, it's probably a good idea to have somebody shepherd you through, right? So my dad told me use anti-seize. I went to school and they told me don't use anti-seize. I went to the job and I got a mentor and I asked him and he's like, oh no, if you use anti-seize, this is exactly what will happen. In fact, we had a truck come in and they had used anti-seize and that caliper, that floating caliper wasn't sliding. Basically, when you push the brake pedal, there you make a lot of brake force when you push the brake pedal. So it would literally push the inboard pad, pull the outboard pad into contact with the rotor. And then when he would let go, the caliper piston would sneak back a little bit, but the outboard pad was still dragging against the rotor. So it wore the outboard pad out really quick. The inboard pad was kind of new and the outboard pad was metal to metal. And he was like, oh, check those guide pins. And so when I pulled the guide pins out, there was a silver metallic grease all in there. And he said, oh, some idiot put anti-seize on there. And I was kind of like, you know, that's what my dad told me. That's all I knew. I didn't know that was bad. I thought that was fine. And so then when we looked at it, he told me, look, when we pulled the caliper apart, the rubber seals inside. So right here, you can't see the whole picture, but a lot of those brackets, these pins will go deep into the bracket and there's rubber O-rings down there. They were totally swelled up. So the problem is with brake components are no petroleum. No petroleum touches brake components. That's brake fluid, that's guide pins, stuff like that. So the petroleum reacts with the rubber, it makes the rubber swell. And next thing you know, that pin is like basically locked in because the rubber's swollen all around it. So at that point, I no longer needed opinions. I saw it with my eyes. I know that anti-seize causes that. So now I can definitively say no anti-seize. What should you use, you ask? I actually have it here. Can someone read this for me? How about this side?
Toyota brake stuff.
Yeah, so somebody gave me this. This is rubber grease. That's what it says. Let's see. Oh, actually, it does say that. Yeah. So this is rubber grease. The other thing you could use that's this is fun and it's great, but good luck buying this if you're at a store. You can get it at your dealers, but this would be my go-to here. You can buy this at auto parts stores. That'd be a good one. So the reason is we can't have petroleum based greases in on those slides and stuff like that. So if you use the correct grease and you put it in the correct areas, you're just going to have a lot less problems. And remember, the disc brakes are more prone to making noise already anyway. And so we really need to be on our A game with how we service these. And so we'll continue, but that was a really critical thing. We need to make sure these guide pins are clean and lubed. And if they're not, we're going to have issues. All right. And they can be different styles. So for example, this one's like, they're square, but this little piece actually gets driven in with a hammer. Those ones are kind of weird. I'm so excited with that Japanese soap grease. I need a little drink of water and calm me down. All right, so continuing, here's your fixed caliper. You look at this caliper right here. What brand name do you think of right away? Four piston.
Brembo.
Yeah, that's
Brembo.
Exactly. That's your typical Brembo right there. But Brembo doesn't have a patent on that design. Four piston fixed calipers. A lot of companies can make those. A lot of companies do make those.
The
But
Tacoma.
yeah, exactly. My Hummer even has them too. So on any of the nicer stuff, the Tacoma has it if it's a pre-runner or a four-wheel drive. The smaller, shorter two-wheel drives, at least the older ones, would have sliding calipers. So it can vary, but this is overall a nicer design. It's more money though, so that's why you don't see it on everything. But basically, this whole housing is fixed. It doesn't move. So that's why it's a fixed caliper. If it doesn't move, then how do the pistons move? Well, as you can see, these pistons are in the bore. There's actually four pistons. One, two, three, and four. And they can move independently. So when we step on the brakes, it's going to actually lift all four of those pistons out of there. But I want to point something out. If the brake fluid, so here's the bleeder. So the brake fluid is most likely going to come in, it may be right here. The brake fluid's going to come in here. It's actually got to go to these two, and then it's got to go through the caliper body, and the caliper split in half right there. Then it's got to go to these two. Well, there's some bolts that hold that caliper together, and that's what the student took apart. I was telling you about. He took those bolts out, and there's O-rings between those caliper halves, and one of the O-rings had gotten out of place. And when stopping the bleeding on the patient, the O-ring got ripped in half. So we had to get some O-rings for it and rebuild the caliper. But this is a nice setup. There's one negative though. They're kind of heavy, so if you wanted lightweight, it's actually going to be lighter weight with a sliding single or two piston than it is going to be with a fixed four piston, six piston, etc. But it may be worth the extra weight. You know what I mean? It's kind of like air conditioning. You can take your air conditioning out, you're going to save like 13 pounds. I'll take the 13 pounds. I'm going to keep the air conditioning. See what I'm saying? So I gladly will get the heavier calipers for the added braking ability. So now you can see what I was saying. This would be the brake hose, goes in, pushes this piston, has to actually go through a sealing surface, pushes the other pistons. Pretty cool. And each one of those will independently squeeze the pad in the caliper. So let me ask you this. If you had a worn piston on the inboard and a new piston on the outboard, what do you think? What are your thoughts? It's probably going to be at least one or more of the pistons seizing in the bore. And yeah, we're probably going to replace the whole caliper. You can also occasionally see where like the top of one of the pads will be worn, but the bottom will be new. And that may actually be one of these pistons seizing as well. So that would be, it could be uneven top to bottom of the pad, or it could be uneven inboard to outboard. But see, on the fixed caliper, there's no slides. Basically this little pin right here, the pads just very loosely ride on there, and they're guided by this, but that it doesn't have to actually slide back and forth. So pretty much it's caliper problem, right? And now when we step on the brakes, you understand how it pushes the pad in. What about when you release it? That's kind of interesting. When we release it, something releases the pad. And in my mind, I thought it was like you're going to release the brake pedal, so it's going to pull the fluid, and the fluid's going to be, pull the rotor, the caliper piston. That's actually not how it works at all. How it works, when we apply, boom, it deforms this caliper piston seal. When we release, that caliper piston seal is like, you know what? I don't like that shape. I don't want to be bent. I want to be straight. And then boom, it just pulls the piston back. So this is a rubber seal. Do you think there's a lot of pressure, a lot of force generated by a deformed rubber seal? Hundreds of PSI or what? Not much. That's right. It doesn't generate a lot of releasing force. So for that reason, it's very critical that when we do our work, we're using the correct grease and we're keeping everything very clean. If there's rust, we need to clean it. If there's some buildup, we need to clean it. So when we do this, we right here, this is all we have trying to retract that piston. We have to have everything clean and good condition. If it's not, the brake pads will probably apply, but they may not release very well. They may kind of drag. If we're dragging the brake pads, do you think they're going to last very long time? It's going to be premature wear. They might tend to get more noise. They may tend to warp rotors potentially. And so the biggest part of doing a brake job is doing a good quality brake job. That's going to fix the most brake problems. So this talks about the different types of grease. It even talks about where to put them. You know, we've got some guide pins right here. We got some clips. We got some shims. It's going to call out exactly where to put those in service info. Additionally, as our brake pads wear, you know, sometimes we have a wear indicator. So this is, you know, this is a nice 10 millimeter pad. That wear indicator is far away, but this one's only one, maybe a little under 2 millimeters. This metal clip is touching, so we may call that the squealer. The book calls it the scratcher. That's going to make noise. That's designed just to get the customer to come back so we can fix that. Make sense? But do you guys know why the customer going to the dealership should never experience this? They should never experience that.
Because we do inspections with every service.
There you go. So if you're doing an inspection and it was 10 and then it was 5 and then you know it's kind of getting lower, so we should be able to predict this. It should never get to that point. Shouldn't.
You know,
then, go ahead.
speaking of that, I heard a story from a service advisor where we told them their brakes were at 3 millimeters, they needed brakes, and he simply said back, well, it's not 0.
Yeah, exactly. And at that point, we would need to coach the customer because as you guys understand, the limit of wear is really 1 millimeter. So 0 means you're like negative basically. So 1 is totally shot. It's interesting if you look at the pads as we will in a moment, the pad lining is held to the backing plate of the shoe. I know it's disc brakes, but the metal part of a brake pad is still called the shoe, believe it or not. It's held by a bonding agent, which is basically like a glue. And when it gets really thin, you've basically the lining is porous, so the glue soaks in. But as you wear it away, there's essentially nothing holding the lining on there. And so even if you're at 1 millimeter, I've seen where the lining will just slip out. Boom, it's gone. So you go from 1 millimeter to metal, like in one stop potentially, because it'll yank them out. So yeah, and then also I saw in the chat, it's true. You can have brake pads that will be worn very uneven one side to the other. So you think everything is cool, everything is good because you looked at the outboard brake pad because it was easy to see like this. You're like, say like this one, you're like, oh yeah, that brake pad out there is good. We're good to go. Well, you could have 8 millimeters on the outside and 5 in the inside, or 8 in the inner and 5 on the outer. It can be different. And if you have that type of inboard outboard difference, that's going to be either the guide pins on a sliding caliper or possibly a sticking piston on a fixed caliper. A little less common. The fixed calipers tend to be pretty reliable. And then we got some tapered wear, some side to side wear. This one's top to bottom of the pad. So that could all be signs of the brake pad is not free to move in the bracket or in the caliper. So it all needs to be cleaned and lubed. That's what it really comes down to. In the correct places, not just oil everywhere, please. Thank you. So, and here's runout. We discussed runout a bit. So, you know, if you want to know what rotor's warped, you go ahead and hook up the dial indicator and spin it. That would be your runout. Very nice. Renee, I see your question. So like I was saying, if you look, inspect the brake pads for sticking slide pins, disc runout. It's really going to be that the pad is not able to move very well inside of the caliper. So if we go way back here, you know what? It doesn't show it all that well, really. Mm, yeah, let me get a good picture on that where I can explain. This will kind of do it where the pads are sitting in that bracket. If there's something wrong with those shims or those clips, that's going to hold your pad up from releasing. We build all the force to squeeze it against it, but we only build a little bit of force with that deformed seal to pull it away. And if something is not clean and lubed correctly, it's going to drag, and that would cause uneven. All right, so rotor runout, you got. That's dial indicator. Parallelism is different. Parallelism would, you could actually kind of catch that on a dial indicator because the dial indicator would move. But the correct way to find parallelism is actually to measure with the micrometer and 6 or 8 points. And basically, run out means the caliper's moving like this, and parallelism means the caliper's thick and thin, thick and thin, thick and thin. And they say that technically runout shouldn't cause a pulsation because the pads should be able to follow the variation. But thickness variation or parallelism, it can be called thickness variation. That's actually what allegedly causes the runout. I don't know. I got to tell you, it seems like it doesn't really matter to me. If I measure runout, if I feel runout, I resurface the rotors, it fixes it both ways. But if you really want to get technical here, you could see the difference. Right. So now we talk about the caliper piston seals. So these are square cut O-rings. It sits in a groove on the caliper, and then that piston will ride in and out against that seal. And if everything's lubed well and everything's in good condition, it will seal and it will last and last and last. But that's not always the case. So like, for example, this one's also describing how that seal gets deformed. That's the seal. That square cut O-ring is the one that pulls the pistons back. Doesn't do it much. And that's also how the self-adjusting mechanism acts. If we apply the pads and if we apply the brakes and the pads are thinner, this piston is going to slide along that caliper, and basically that O-ring is just going to grab a new spot, right? It's not stuck in the same spot. So as the pads wear, that piston will continue to go out, 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 out. Seal's got no issue with that. It'll continue to work. Then of course we can have some failures. But here's one. This will tie back to the master cylinder one. You remember we talked about the quick take-up master cylinder? How the guy hit the brakes and the quick take-up part wasn't good and it knocked the truck off the lift. Well, this is a caliper that goes along with that quick take-up. Quick take-up goes with low drag calipers. These low drag calipers, if you look, this caliper piston seal deforms much more. It's a much longer seal and it deforms much more. So then when we're done, it's actually going to pull away much further. It's going to leave a bigger gap. So this would be standard caliper right here. This is a low drag caliper. It's going to pull the pistons way back in. Now that's a problem because the first time you hit the brakes, it's going to go to the floor. But that's why they have the quick take-up master cylinder, so it doesn't, assuming it's working. And it wasn't on the car that knocked mine off the lift. But the positive of this would be if we pull the caliper pistons way back, that means we pull the pads way back. The pads are really not dragging at all. And that's going to give us better fuel economy, lower emissions. That's what this move was all about. Now, here's an example of a caliper bore. So the piston would slide in here. The seal is missing. What do you guys see about that caliper piston bore? Don't look good, does it? Do you think a caliper and a caliper piston are going to be able to hold up very well? Especially if your piston looks like that and that rust is going to be drug across that nice, soft, sensitive rubber seal. What do you think is going to happen to that nice, soft, sensitive rubber seal dragging its face in this rust? Yeah, I think we have the same idea. So essentially, if you have rust in the caliper, that's going to cause the seal to be torn, and that's going to give you a leak. So part of the reason we want to look at this is if the vehicle's old and it's not had a brake flush, we could actually have droplets of water forming, and that's going to cause the rust, which is ultimately going to make the seal leak. Now, this same thing is true for a master cylinder. So if we have a master cylinder with pitting and corrosion on it, the master cylinder seals, the primary and secondary cup seals, are probably going to leak. Same with the caliper, right? So brake fluid maintenance would be preventing this. If it's too late and this already happened, the fix is to replace the part. Now, technically, we may actually be able to take this caliper off, pop the piston out, take the seal out, hone this and clean it up really good, put a new piston seal in, clean the piston good, lube it up, put a piston in. We may be able to rebuild that. But if we rebuild it and it fails, who's liable? Oh, we're liable. So it's much more common practice and probably a little safer bet to replace it because someone else probably rebuilt it. You know, if you go to O'Reilly's, trust me, they're probably not selling you a brand new caliper. They're selling you a caliper that was rebuilt, probably was not in the US, by the way. And they've done the honing, they've cleaned it, they've lubed it, they put the new seal in, they put the caliper in. If that caliper leaks, the liability's on the rebuilder, which was a different company. See, so some of this is just, it's a hot potato. We want to pass the buck to somebody. Additionally, it takes time to rebuild a caliper. And unfortunately, you Americans, your time is too valuable. It doesn't make sense to pay $150 an hour to rebuild a caliper when I could buy a caliper for $60. Make sense? So it's just crazy when you figure what the employer is going to charge to pay you a lot less. Right? So that's just the way it is. It's not that we can't fix them. In this week, you guys all get the chance to pop a caliper apart and take the seal out and lube the seal and put it all back together. You'll know how to rebuild a caliper. You will most likely not rebuild a caliper, but I have had an exception. We had when the brand new Tundra came out, caliper leaking, calipers were not available, but the seal was. They asked the line technician who was a former graduate, can you rebuild it? He said yes, and he did it. And so still something we're going to cover, but it's not something you're going to see all that often. Right now we got the O-rings, but we also have different types of pistons. So this one, for example, is phenolic. Phenolic is a type of plastic, basically. And this one is more like an iron or steel piston. That's why it's rusting. Phenolic won't rust, but I have worked on quite a few vehicles with these phenolic. You think that it's a better design until it gets a little bit seized and you start trying to push on that caliper and it'll crack. It'll crack, it'll break right apart. I think they're junk. What do they think? Well, phenolic pistons transfer heat more slowly than steel pistons. So if you have a hot caliper and a hot brake pad, the phenolic is not going to pass the heat into your brake fluid as quickly. So it's better for, hydraulic brake fade, where you basically, your fluid boils. But as far as durability, trash, if you ask me. You could probably push this one back with a C-clamp, and this one, you better not look at it wrong or it's going to be broken. That's what I'm saying. Now, here's the difference. Bonded versus riveted. Bonded sounds good. Licensed and bonded. Bonded. Just based on the name, I want bonded brake pads. But now let me give you the ugly side. All bonded means is glued. So if they said, I want glued together brake pads, you think it's Elmer's glue, and you're like, oh, heck no, that was a glue stick. I used to lick those. No. But it's a good glue. It's a type of adhesive, but it's glued. So, they're fine. But the reason they actually had riveted ones, these tend to be a little more heavy duty. But what's interesting is they all used to be riveted. So if I were to take you way back in the day, I didn't do this, by the way, but I worked with a guy. It's kind of a jerk. He was like just close to retirement when I was just starting. Just rough, just, I don't know. You guys at school, and we have a really good time, but when When I go to the shop, man, this guy was rough. Always felt like he was picking on me. His name wasn't Mo, his name was Bob. But I'll just say, he told me, "Oh yeah, we used to redo those. We used to drill the rivets out, and they'd have actually a big board, like a big sheet of brake lining material, and you'd actually trace the old one, and you'd cut the brake lining material, and then you drill holes, and you'd get new rivets, and you'd actually rivet new brake lining material on this metal shoe." That's what they'd actually do. Then if you notice, they have a little angle right here. They'd actually grind those. They'd arc grind the shoes. They would refurbish everything. So you didn't have to buy new brake pads. All you had to do was cut a sheet off of the, cut a piece off of the sheet of lining material and rivet it on there. So it's really cool hearing how stuff used to be. They used to get 50% of the door rate. So if a customer came in and their bill was $500, they'd get 250 of it. So they were getting half. Sounds really good, but at the same time, the work was way different. That was like when the labor rate was a lot cheaper. So the car would come in and we wouldn't like knock out a gravy job. We'd be like, all right, we're going to work on one car. We're going to do this maintenance, that maintenance. We're going to cut the brake pads, rivet the brake pads, obviously resurface the rotors. We're going to rebuild the steering. We're going to rebuild the rack and pinion or the steering box, so it's just way different back then. And so you're probably not going to see a whole lot of riveted, but you might see some, maybe on something a little heavier duty. All right. Bonded is much cheaper to build. And so it's probably not going to be something that fails, but the rivets are going to be a little more reliable, I'd say. Right. And so here's part of the brake pads you got to understand. They have these locating lugs. So these little ears right there, and I had some brake pads. I might take a look for them in a second. But these little ears right here, that's what locates the brake pad in the bracket. That's also what we need to make sure is nice and clean. So if we have rust buildup on those locating lugs, that's what's going to make the brake pads stick in the bracket. So that'd be a point to clean. Now, in another video, I installed some aftermarket brake pads, and they were just not machined all that well. They were a little too big. So those pads were actually sticking in the bracket. And the only way to fix it, it wasn't that they were not clean. They were clean. The only way to fix it, I had to actually sand them down. I filed them down to get them to fit well. So when you're putting brake pads on and they're OEM, you're making sure stuff is clean. You might have to clean some rust. But when you're doing aftermarket stuff, you got to double check that for proper fitment. So if I slide the brake pads in, I should be able to move them pretty easy like this. I should be able to move that around. And if I can't, I need to figure out why. I might need to see what's hitting, what's too big, figure it out. And then those little clips will come back to, most likely those will come with the replacement pads. There are times where the cheap ones don't. So you may have to actually take those off and clean those up with a brush as well. It can be kind of a pain. Now here's something I want to show you. Anybody ever got punched in the lip? I already, like before, I'd say you've been punched in the lip, everybody was a yes, but now I don't think everybody gets punched in the lip anymore. You get punched in the lip, what happens to your lip? You get fat lip. All right, fat lip could mean two things. Fat lip could mean you got punched in the lip, but fat lip could also mean, look at this brake pad. Do you see right there, there's an edge? That's a fat lip. And so that's basically the reason for the fat lip is because the brake pads have worn and worn and worn and worn their way into the rotor. If they've worn their way into the rotor and they don't cover the whole surface of the rotor, they leave a little edge exposed, you can kind of feel a fat lip left behind. So that fat lip can actually cause some noise because it tends to rub on the side of the pad lining that it's not supposed to. But also, if it's got a fat lip right there, that means that more inner part of the rotor has got a lot of wear. What's that kind of telling you as far as getting ready for what you're going to sell the customer? Think it's going to be a resurface? Or, that one might end up needing rotors. They might be too thin. that point. But you'd actually really have to measure it if you wanted 100% no. But that's like a quick, that's a quick flat rado trick. Is like if you feel a fat lip like that, you're gonna be like, oh no, they've been pad slapping these rotors several times. They pad slapped their brakes. Like that right there, I guarantee you, was more than one pad worn out up against that rotor. Pretty much can guarantee it. And so now let's discuss the lining materials. So what I was telling you about that guy, Bob, Bob Chrysler. Yeah, he had a good heart, but he was just a little rough. When he was doing that work back in the day, you know, grinding the linings and stuff, think about that. You're breathing in that dust and material. You know, back in the day, it used to actually be asbestos, and asbestos was definitely cancer causing. But it's been many, many, many years. I mean, figure I started that dealership in 2006 and he was about to retire. So, like, we're talking about probably in the 50s when he was there. You know, when he started, it'd be like in the 1950s, probably. The guy was old. And back then, they used to start working young. So he might have started late 50s, probably. They haven't been asbestos for so long. We don't really have to worry about it. But if for some reason you were to work on a car, like a 1970s or earlier car, there is a chance those brake pads could actually be asbestos. So they're looking at materials that are going to have a moderate coefficient of friction. They used to be made from asbestos type compounds because the excellent heat resistance, but asbestos is no good. So brakes now can be manufactured with maybe like non-asbestos organic, they'll call NaO, or low metallic non-asbestos organic. Come back to that. Semi-metallic, ceramic, or carbon fiber. If you go to the parts store, you could actually ask and figure out what you're going to get. Let's back up one. This is old school, and this was like the replacement for old school. And then when we get into these, semi-metallic has some positives and has some negatives. Semi-metallic pads stop well, they stop great. The negative is semi-metallic pads tend to be noisy. If you look at the pad, you'll see little metal chips in there. That's how they're made. They're going to stop well, but they're going to occasionally squeak. They are what they are. They're going to squeak. They might not squeak all the time. They might squeak when they're warm. They might squeak when they're cold. They might squeak when they're hot. They might squeak when they're wet. They're probably going to make noise. But they're pretty cheap and they stop good. So if you don't want to squeak, I wouldn't go with semi-metallic. I'd go with ceramic. Ceramic is going to be more like just gray. They actually don't stop as fast. But and sometimes they're low dust, but they're not always low dust. But the dust is a lot easier to clean. It's like just gray dust, whereas the semi-metallic dust, sometimes those are actually kind of like metal. You'll go to clean your wheels and you'll see little sparkles, and it's like, what the heck? That's the metallic out of the semi-metallic brake pads. So the ceramic, I'd say, would be quieter, generally cleaner, but they actually don't stop as well, and they're more money. So back in the day, if you went to the parts store and you asked for brake pads, they were giving you semi-metallic, I'll tell you right now. And then if you're like, well, can I get something high end? And they're like, oh, you want the ceramics? And it was sort of like, yeah, I don't want to hear the squeak. And they said, oh, wow, okay, yeah, we got a special order of those. That was rare. And then everybody started catching on and realizing, like, hey, my brake squeak, this sucks. And they say, oh, you should have done ceramic. Then everybody wanted ceramic. But the thing was, it used to just be semi-metallic or ceramic. Then they started doing like semi-metallic with more ceramic, but it wasn't all ceramic. It still had the chips of metal in there. And so they were still kind of noisy. And then, you know, you'd get them and you say, are these ceramic? And they'd say, yes. And then I'd get them home and go to put them on the car and be like, what the heck is this? These are semi-metallic. Call them and they'd be like, oh, well, they say ceramic. Matter of fact, they say ceramic right on the box. So it's kind of silly. You're probably going to find they're somewhere between these two. The Toyota OEM, if you look at them, they're just gray. That's just legit for real metallic. Sometimes the more basic ones, like the Toyota Care pads, they may not be so ceramic anymore. And the cheap pads are definitely getting more on the metallic side. So if you really want OEM sound, you're probably going to need OEM pads. And they're going to be double the money, and the customer may not want to pay. But at that point, you got to make it clear you're going away from what the car came with. So if it sounds a little different, it's not because I messed something up. You're getting a different product than what it came with. So just keeping everything on the up and up. Generally at the Toyota dealer, we don't even give them the option. Right. And then yes, they do have carbon fiber. I saw the chat. The carbon fiber pads are just the carbon fiber pads. I have carbon fiber pads on my bike right now. They're all right. They're nothing real crazy special. This is not talking about the carbon ceramic rotors. That's different. We're going to come up to those. So carbon fibers, fine. It's not real common, but you can get them. And then SAE, which is Society of Automotive Engineers, they call for edge code listing. So FF, that's the friction, the coefficient of friction. So if you look, C would be less than 0.15. F, for example, is 0.35 to 0.45. That's how much friction they have. That's their coefficient of friction. And so they're going to be just, they're just going to be classified. FF would be common. FF would be the most typical. So if you were to say like the less friction, the harder the brake pedal must be applied. So if you had C, you're going to have to press the brakes really hard. But I don't even know if you could buy C. I really only see basically OEM replacement, just basically FF. So that would be fun. And then, again, disc brakes are more prone to annoying brake squealing. And so we're going to cover that. What is a squeal? A brake squeal is vibration. What? I thought a vibration was a brake pulsation. All right, well, think about this. Y'all got ears. How do you have ears to hear? Well, you have a drum in there, your eardrum. And vibration on your eardrum registers as sound. So if you think about it, sound is vibration. What? It is. If you have a speaker across the room and that speaker is receiving signal to make music, it's going to be pulsing a magnet, which is going to be pulsing a cone, which is basically going to be vibrating air with the cone. And the vibration is going to be through the air, is going to be picked up in your ear. So I really just gave you very good evidence. Sound is nothing but vibration. Well, the same is true for brakes. So when your brakes are squeaking high pitched, that would be a very, very high rate of vibration on the pad. When the pad touches the rotor, especially, vibration would be sound. So you're going to consider these anti-noise measures generally are just something to reduce, decrease small vibrations. Not like resurfacing a rotor that has runout, though. That would be a vibration that's like much lower frequency. It wouldn't be a sound. Sounds are high frequency generally. So one thing to consider, manufacturers begin to use softer linings with a higher coefficient of friction, which are less prone to noise. So that's possible. Hard brake pads are going to have more noise. They're also going to last longer. And that's tends to be like, you guys have heard of warranty for life brake pads at AutoZone. Yeah, they don't want to just give those away. They're going to make those brake pads pretty hard so they last a long time. Because when they are worn out, you're coming back for your freebies, right? So if they're hard, you think they're going to be quiet? Probably not. But they are cheap, and you get what you pay for sometimes. All right, so here's some examples. We got shims. We got clips. We got anti-rattle clips. We got boots. We got all sorts of stuff. This is another type of a spring-loaded brake pad. So anything that's going to hold the brake pad more still and not have it move around so much is going to help with noise. Also, like a little bit later, Toyota will call for putting brake grease under the shims, and that's going to basically cushion the brake pad even more. They do also have disc brake quiet. There's two types. There's one that soaks into the lining, and then there's one that sits on the backing of the brake pad. So basically, where this brake pad sits in the caliper, you'd put some goop right there. It'd be like orange. It's essentially like RTV almost, like Fitbig. So we have lots of different ways to minimize that vibration. Here's another example. Here's the shims clipped on, but also here's a groove. Sometimes they contour it. So like when the rotor comes across this surface, this little chamfered edge is going to actually help it be quieter. When the brake pad's squared off, they do tend to make a little bit more noise. That guy Bob actually showed me that when he was putting pads on, he started grinding extra things on the sides, and I was like, "What are you doing?" It's like, "Oh, I'm chamfering my own brake pads," and I was like, "You're doing what now?" And he was telling me that's what they used to do. They would put their own little angles on them because they knew what was going to be quieter because they had a lot of experience customizing their own brake pads. Right. And so there's some examples. And then wear indicators, as we saw, so there's like I said, the book calls it the scratcher, but there's your wear indicator. Another type would actually be a warning lamp. So you may see, especially on some European cars, the brake squealer is not good enough. They want a light, and a light they can have. So this is not the red brake light. This would actually be a low brake pad or low brake warning. Different. We basically send 12 volts from ignition through the bulb, at which point 12 volts will go all the way down into basically this little element, and 12 volts will be sitting there chilling. So the light's off because we have 12 volts going all the way through. In other words, there's no ground until the pad lining wears, and then the metal from that sensor will actually touch the rotor, and the rotor's grounded. So the second it wears down and now you have metal from the sensor touching the rotor, what happens? Aha! It gives it ground and now the light's on. So I worked on a Sprinter and it had this light on. And I told him, yeah, let me check it out. And I looked and I was like, your brake pads don't really look worn. But the problem is I'm going to really have to take it all apart to do this diagnosis. When I got it apart, what happened was the guy who did the brake job previously messed the sensor up. It wasn't clamped right. And it was actually literally had rubbed through and was grounded out. So it was kind of like an electrical diagnosis. Really, it had nothing to do with the brake pad thickness. The problem is the sensor a lot of times can be like part of the brake pad. So if you want a new sensor, you got to get a new brake pad. So I'm like, well, you need new brake pads. He's like, I just did them. I said, yeah, but the sensor is part of it, and the sensor wire rubbed through against the rotor. So I can't replace just that. We need new pads. See, so this is a different design. Sometimes the sensors are separate, like they just clip on. In fact, I have some somewhere. But there's those two types. And then here's an example of like inspecting the squealer. There it is. It's got a distance, so that shouldn't be making noise. And here's the low brake pad warning. Right. And then this is just kind of talking about pulling the brake pads apart. And so we'll go through some. This is what you're going to be doing in lab tomorrow and the next day. So pulling the brake pads off, inspecting hardware. Here's new clips. If it comes to new clips, you should use them. Sometimes I find if these are just slightly bent though, you'll go on a road test and you'll find the clip is actually rubbing the rotor. And now to fix it, you got to kind of redo the job. And you're like, oh, those junk aftermarket clips, you had to do double the work. So that sucks. But most of the time they're good. Here's obviously measuring the brake pad thickness. Should be familiar with. Now, let's talk about parts. Here's a rotor. This rotor is considered composite because it actually has stamped steel in the center and cast iron on the outside. Any composite rotor is two different metals. Cool. And so we'll continue. Some could be heavy duty, high performance. Some are made of reinforced carbon ceramic, different composite ceramic substances. So we will come with that. Motorcycles typically are stainless steel because they're visible. We want them to look good, pretty much. So here's an example. This part's all the knuckle. This part right here is the hub. See, that hub is kind of rusty. So I might have some concerns about that hub, but this silver part right here is mostly where the rotor touches. So that's the important part. We don't necessarily have to have every square inch of rust off of there, because a lot of times this brown part right here is a little low. So that doesn't actually touch the rotor, but still, that's what I'm talking about when I say the hub. That one happens to be a hub and bearing assembly. Then we got the splash shield. Well, the splash shield has a name. What does the splash shield do? Well, it should keep stuff from splashing on the rotor. We're not so much worried about water. They can get wet. We're more worried about grease, oil, lubricants. We don't want a transmission fluid leak to all of a sudden be splashing ATF on our brakes, and then we go to stop and we have no brakes. Make sense? That's why we have the splash shield. Sometimes they'll call it a dust shield as well. And then rotor types, what's the difference? A is solid and B is vented or ventilated. This one's going to be pretty light duty, maybe found on the rear. This one could be found on the rear, but it's a little heavier duty, so it may be found on the front. You can tell one of them is going to handle heat better than the other one. I think you can guess. And here's that ventilated rotor. So it's designed that, let's say that the air is coming in from the left. It goes in sometimes through ducting, various ducts on the front bumper, like performance actual ducts would be pretty cool. But on a basic car, it's all right. We don't need a whole lot of ducting. Air will come up, hit the dust shield or splash shield, which a lot of times are opened up in the front to scoop air in. It scoops air in, it runs in the vents, and then a lot of times will discharge through the center and out. So it'll come in like this and out through the center, and that will keep that rotor nice and cool. Cool. And then sometimes they're directional, but generally that's more like drilled and slotted, which we'll cover. Can't put those on backwards. You can, but you're not going to like it. And now here's an example. This, for example, is a carbon ceramic. So, and this one is actually the Z06 Corvette with the Z07 package. So if you buy a Z06, it comes with regular composite rotors, which have a stamped steel center and a cast iron surface. But this is the Z07 package, which I think something like about $15,000, $20,000 option. But it comes with these carbon ceramics, which we will discuss in just a moment. You can, if you buy an LFA, you get these. They just come with it. LFA, it's not optional. They all come with these. I have one in the room. I'm going to show it to you. But this is very high performance. The positives, oh yeah. It's nearly as hard as a diamond. So they don't wear down much. The material has a low thermal expansion rate, which prevents it from deforming, especially under heavy braking and heat. It's totally resistant to corrosion. It's got very nice low noise. It's dampening. It lasts a long time. The drawback, there's only one. If you had to do 4 rotors and brake system, that's going to be somewhere around like 6 to 12 grand. And yes, I do have one from an LFA in the room. I'll show you. All right, but here, for example, is your drilled and slotted. So they do actually make rotors that are just drilled, or rotors that are just slotted, or they make rotors that are drilled but not all the way through, and they just call them dimpled. This is generally to give a little bit of air to get underneath the pad. So if the pad's on the rotor, it traps a super hot gas. It's hard to get it out. So when it comes across those vents and slots, that's a way to get the super hot gas out to give extra cooling. So the drilled and slotted rotors are going to generally run cooler. If you had a car that was continuously warping rotors, you could consider putting the drilled and slotted rotors on there. And I have seen it fix quite a few. But those are not Toyota parts. Those are aftermarket parts. So they're not going to carry a warranty. And sometimes they do sound a little bit funny. You tend to hear them a little more. But Not a bad design. And then, of course, on the edge, you may see minimum thickness spec. So 9.5 millimeters is the minimum thickness. Just for your reference, when you're doing the rotor resurfacing, you need to make sure you don't cut them below the minimum thickness. Cool. And then, for example, if we had a rotor that we had cut too far, so this rotor is at, let's say, well, let's say it's at a standard thickness first. If you did a moderate, if you went down a moderate hill, braking fairly hard, you might get the rotor up to 400. But if you did the same thing with a rotor that was below the minimum thickness, it would actually get hotter and potentially overheat and potentially boil the brake fluid and cause your brake fade. And here's the reason why. When you're braking, you're making a lot of friction. That heat has to go somewhere. Some of the heat goes to the atmosphere. Love it. But some of the heat goes into the rotor. And if you have a thin rotor, it can only absorb so much heat before it gets hotter and hotter and hotter. Having a thicker rotor is almost like having a deeper cup. It can take more liquid before it overflows. It can take more heat before it actually gets too hot, basically. So when our rotors are below minimum thickness, they expect it to not be able to handle enough heat. The thicker our rotors are, the better heat they're going to handle. So the reason I like to cover that is, let's say you have a customer and the customer comes into the shop with low miles on their car. In fact, there's one right now that I know of. He works for Campus Safety and it's a Highlander hybrid. And he brought the car new. Within like 5,000 miles, he had a brake pulsation. Rotors were warped. He brought it into the Toyota dealer. Toyota dealer took a look and said, "Oh yeah, you've got runout. We got to resurface your rotors." Why do you think resurfacing the rotors may not have been the best plan for that one? Help? Well, the customer already warped the rotors with them at full thickness. So now you cut some metal off of them. They're a little bit thinner now, given they're not illegal. They're still fine as far as specs go, but you still took some metal off, which means they can handle less heat than they could before you took the metal off. See where I'm going? So what do you think happened in another several thousand miles? Warped them again. And then they said, "Oh, well," and by the way, defending the Toyota dealer, we have to follow protocol. Toyota's paying the bill. It's no cost to the customer. They're going to want us to resurface them. So, but I'm just saying, to fix it right, it actually would have been better to replace them. So he comes back with them warped and they said, "Well, we can't cut them again. We've already cut so much material off. So you got to get new ones." So they had to put new ones on there and the new ones lasted longer. But unfortunately, they pulsated again. And that's, truth be told, I actually don't think there's anything wrong with the car. I think he's driving it really aggressively. If you gave me any car, except for cars that had carbon ceramic, I could warp the rotors in the next 5 minutes, even if they're brand new. So I kind of think this is more of how he's driving it type of thing, but I still follow the logic. When he came in, I said, "Well, take it back and they'll put new ones on there. And if the new ones don't last, then you're going to have to do something." But it's feasible that if you're overheating your rotors and warping them and they've already been cut, that putting new ones on may actually fix the problem or at least make it less likely. Follow me? Because the mass of the metal. Okay, very good. And so we continue. Let's go over some of the tools, just so you're all familiar for tomorrow. You all know about these to measure the brake pad thickness. You all have seen this. This one's filthy, but this is basically, because it's a school, we're not billing customers for brake clean. You guys used a ton of brake fluid. That was crazy, but I had it, so good to go with it. We can't do that with brake clean. You can't be using 2 cans of brake clean for every car that you use. You can't even really be using 1 can of brake clean for every car. That stuff costs real money. So what you get is the brake parts washer. And you actually may find you like it better. You can roll this blue thing under, hook it to air, and you can scrub the brakes any which way you like, and it all drains right back into the blue thing, and you're good to go. So no brake fluid for you. You get brake parts washer. Here are, I think that those are pinch off pliers. Let me go back one. I'm trying to remember those pliers. Oh, parking brake cable pliers. Pretty rare to see those. So we got a couple of tools I'm even a little unfamiliar with. The dial indicator kit, very common. A specific disc brake micrometer. Notice this comes to a point. That's to actually help you get a better measurement for when the rotor's kind of got some grooves in it. It'll get down in the groove and get you the lowest measurement possible. This one I remember being for parking brake cable as well. Here is the, there's two different type of caliper piston compressors, but this one spins. So this is a type of caliper that has an integrated parking brake. You can't push this back. You have to actually turn it and push at the same time. This is a tool for that. And then there's, of course, the off-car lathe, the on-car lathe, bushing and bearing driver's kit. So this might be, yeah, there's a couple things we might use that one for. And so, good. Now, different concerns. Typical concerns would be something like poor stopping, noise, vibration, pulling, grabbing, dragging, pulsation. That's pretty much what we get. I'm going to tell you 9 out of 10 times what the fix is for a brake concern is just doing a proper brake job. Even if someone else had just done it, let's say they come in and they had just had their brakes done, but the person used cheap pads. They didn't cut the rotors. They pad slapped it. They didn't grease the correct points. They didn't do proper cleaning on the caliper. They didn't use the correct grease, right? I mean, these are 9 out of 10 brake concerns that we see. So if you want to have a lot of comebacks, skip the details and see what happens. Customers be coming back with noise concerns, potentially pulsation concerns, premature wear. So the biggest thing I can say over the next several days is I want you guys to do a really nice, precise, proper brake job. And that way I know you're not going to be having a ton of comebacks. One of the things that would come back is when you're cutting the rotors and you get that wong, 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 wong. That's the chatter. That car is going to be loud when you hit the brakes. That car's going to come back. I already know that car's going to come back. I already know that car's going to come back because the car that I did like that came back and I learned my lesson back then. So I can speak not just by repetition of the book, but by experience. So we're going to work on getting these things dialed in. And then, for example, let's say we're going to remove, inspect, replace calipers. First things first, the way that I do brakes is the way that probably at least 80% of technicians are going to do brakes. I'm just going to unbolt the brake caliper. I'm going to move it out of the way. I'm not disconnecting the line. I'm not opening the bleeder. I'm not doing any of that type of stuff. And so when possible, I don't open the hydraulic system. Kind of make sense? And so we're going to have to remove it. But what I'm going to do is I'm going to remove it, keep it attached, and I'm going to hang it to do the work that I'm going to do, like quite a few people have done. And then I can, let's say I was really inspecting, you know, if a car came in for a brake inspection, I'm not pulling calipers, but if it was for a brake concern, like a noise or something, I might actually have to. But pulling a caliper is not a big thing if you do it like that. Right. And then here, for example, would be to push the caliper pistons back. I actually have a tool here as well. And we've got several types. Oops, that was my microphone. In fact, this is the exact same one we have at the school. This one was like, everybody had to have this one back in the day. I think this is still kind of the most common. It was like the 4-in-1. When I go to pump this, I'd be pushing them back. when I go to retract it, I need to push the handle forward, like this handle this way, and squeeze it right there. See that? Boom. This is probably something I would say to get. In fact, I put it on the custom toolkit that I have made up. It's on there. It's slightly different one. I didn't do the foreign one, but that one's pretty good. I actually don't really like this type that's shown on screen. But if it's an integrated caliper with the parking brake in it, that one I just showed you won't work. You need something more like this, or there's one more tool. I'll show you that with parking brakes. There's one more tool that I have that can push those back. That's much more basic, but it takes a lot of, you have a lot of hand strength to use the tool that I have, but it's universal. It fits everything. It was cheap, so I like it. Right. And now I'm going to show you the cube. Yeah. The cube is what I like. The cube or the OptiSpark, I call it, or the AllSpark. I've called it the Tesseract. But right now we're going to walk through the skill drill, which is how to do the brake pad service. In fact, this is really just inspecting the caliper, but I wrote this, not how I would do it. Okay. So I'm telling you, I wouldn't do it this way, and I don't want you doing it this way, but there are some people who tell you this is the way to do it, and I'll explain their logic pretty soon. So when you're about ready to remove the caliper, we want to loosen the bleeder screw, don't tie it, and then tighten it. There's a little bit of logic right there. The reason why, well, you guys tell me. Why would we want to loosen it and tighten it? Okay,
Soften,
go ahead, shoot it, Abdul.
softens the piston, so when you wanna like take the caliper out, they could go back in easier.
True. So there's two logics. One, if all you're going to do is loosen it and tighten it, you're just basically making sure that the caliper bleeder is not seized. If your bleeder is seized and you do this whole job and you can't crack it loose, then you can't bleed it. You wouldn't want to know first. So I'm just making sure that it's not seized is good. But the other thing that they're kind of more leaning toward is, yeah, loosen the bleeder and then push the piston. If you loosen the bleeder, you can push the piston back with your hands. Problem is, now you got air in the system. So what do we need to do when we're done? We need to bleed it. I know you knew that. So, you just added time. Now, as you continue, it's going to say, pull a little bit of fluid out of there. Remove it. This is a good trick. Applying the brake pedal a little bit so that the compensating ports are blocked so that fluid doesn't drip, run out. It'll kind of stop. So that was a good trick. And then, disconnecting this bolt right here is called the banjo bolt. Ding, 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 ding. It's a bolt with a hole in it, and it has a copper washer and a copper washer. So it's kind of like it's like a sandwich. A sandwichy. The meat is the brake line and the bread is the copper washers. You need to have both pieces of bread. Copper washer to seal the line, the hard line to the hard caliper. It needs a soft washer as a gasket. And also the hard line to the hard bolt needs a soft copper washer because it's a gasket. So we need two. Remember I said that earlier, if you drop one, it's not going to seal up. And they do sell those separate, by the way. And then, to be quite honest, if I'm changing rotors and pads, I will actually use a screwdriver to push the piston back. But definitely not if it's a phenolic piston. That will absolutely break the phenolic piston. Don't ask me how I know, because I think you already know how I know. Okay. And then it's saying, I don't know, a pry bar, a C-clamp's the safer choice. Probably not. I would probably say the caliper compressor is the safer choice. But sometimes I will do this. I keep a good set of screwdrivers. Show you. Look at the tip on that. It's nice. That is not what I would be using. I keep a cheap set. Cheaper. Look at the tip on that. Not as nice. Okay, so I'll do use the screwdriver for prying, but I keep a really nice one for, if it's a screw that actually needs a screwdriver. They're pretty much repurposed little pry bars. Right. So removing it, etc., hanging it, inspecting. So right here, this dust boot is not the piston seal. This dust boot basically protects the piston seal. So if this boot is worn or torn, if that boot is ripped or torn, it doesn't mean it needs a caliper right now. It means water, rust, things are going to be, road debris are going to be getting into the caliper area. It's probably going to rust the piston and bore, and it's probably going to cause the caliper piston seal to leak. But not right now. So you're more than welcome to sell a caliper for a torn boot, but you should specify it's a torn boot that's going to cause the caliper to fail. Not that the caliper failed. It's kind of the same when we get into suspension parts. If you have a ball joint that has a torn boot, that doesn't mean that the ball joint's bad. It means the boot is torn, which means the ball joint is going to fail. Make sense? It's like the first stage. So as long as you're clear with the customer, you're welcome to sell it, but I don't think you should. I think you should paint as clear a picture as possible so they know like it's not super urgent today, right this second. So yeah, that's the kind of thing. And then, this shows cleaning it, pulling the guide pins out, cleaning the guide pins up. When we go to disassemble the caliper, for example, this is how we do it. We'll actually put a block of wood there up against the piston, and this is a blowgun. We just pop it right out of there, get all disassembled, keep it neat. If you wanted to do powder coating on your calipers, this is what you do. Pop the pistons out, totally disassemble it, send them to powder coat, or maybe build a powder coating thing at home. And then once it's powder coated, you'll actually put a new seal in, put a new boot on the piston, push the piston back in, and have some really nice powder coated calipers. Right. So now if you look, this one has some rust. So that rust has to be either extensively cleaned up or possibly that piston replaced. But then the caliper bore is messed up too. So we either need to hone that. That's why I said hone, which should take the rust off, or possibly replace it. That one's going to be a little tougher to clean. That one likely had water in the system. And then sometimes when we're doing the rebuild, they'd actually call for caliper bore to piston clearance, but you're never really going to do that. All right. And then making sure the rotor's on, lubricating the seal with brake fluid, but we also have some special lubricant that's brake fluid based, but it's a little thicker, a little more protective when you go to slide it back together. So we have something special. Reassembling it nice and clean right there. We got special lubricant on the guide pins. That's one of the things we're going to do. It's a little concerning it's red because that looks like it could just be generic wheel bearing grease, but we'll give them the benefit of the doubt and we'll say that's proper disc brake caliper lube. So if it says disc brake caliper lube, that's legit. If it says wheel bearing grease, that's not legit. I'm not sure which one that is, so I can't say. Right, and there's our sealing washers right there. Sometimes they're connected by a little tab. Those are kind of nice. If you're replacing a caliper, they'll most likely come with these sealing washers. And you should use them, but sometimes I find the new ones actually don't work as good as the old ones, but you can't really use the old ones on a new caliper. If I'm removing it and then reinstalling it on the same caliper, I may very well use the old ones. And I just make sure that they're sitting where they were when they came out. So I don't let them get switched. But regardless, whatever you do, when you're done, have somebody step hard on the brake and look very closely to see if there's a leak. Don't just cut it loose. You got to do that. All right. And then as you can see, we're torquing these to spec. Very nice. Pumping the pedal before we move. Let me help you with this. I don't think I told you this, but maybe I did, but I don't think so. So when we went to, no, we didn't go there. When we had students working at I'll put them on the spot. Toyota of Orange, it's a good dealer and probably, Bao knows about this. There was a time where a line tech did a brake job and then the line tech had finished it and the service advisor was kind of pushy for it, like, hey, I need the car, I need the car, I need the car. And they sent a porter to go grab it, and the porter just jumped in, chucked it in reverse, went to hit the brakes, but see, the line tech had just done a brake job. So the pistons were pushed all the way into the caliper. So when the porter hit the brake pedal, pedal went to the floor. They were backing up and it actually hit a guy and crushed him up against the wall. And like, I think it broke or really messed up his legs. Yeah, it's a true story. And so they made a new policy, you know, the line technician has to be the one to pull the car out for a brake job, because if you don't know to pump the brake pedal several times and firm the brake pedal up, it's not going to stop the first time you hit it. It's kind of horrific. So that's the reason why. Okay, I want you to remember that. And then with various different bleeding techniques, which you guys have learned one way or another. Okay. And now retracting on the integrated parking brake system. It's like this. See these pistons, how they're solid and they have grooves. We actually need to use this special tool with these pins, and these pins are going to engage right here and they're actually going to turn it. Right, so that's how you know it's a parking brake style one, like I was saying. And so you can see it engage it right there. As you're turning this, you also need to pump it, and this is going to bottom out right here and provide pushing, and you're going to turn it. So you need to push and turn, which you could do with the cube, but with the cube, you gotta, you like, you know what I'm saying? So the tool makes it a little easier. I just don't care. And then make sure the dust boot looks good, because if the dust boot is twisted, a lot of times it'll no longer seal, and then you're getting contaminants in there that are going to ruin the actual brake caliper piston seal. Cool. And then let's say we're going to do rotors. We're going to talk quite a bit about, some of the more measurements, like you might replace a rotor because it has thickness that's too thin, has too much runout or thick or variation. And so this is assuming that there's something wrong that they can't be resurfaced, right? And so, I think you understand these measurements. Cleaning it, looking for defects visually. So that's something that I want to make sure that you understand. You still need to do that. It's not just measuring, you're looking for defects visually. This one has such bad grooves in it. It went metal to metal. That's no go. Junk it. By the time you try to clean all that stuff up, you'll have taken a ton of metal out, and it just doesn't make sense. Additionally, if it has hard spots or hot spots, I'm gonna group together. I mentioned this once, but the hard spot is probably going to be due to a hot spot. So when you get metal hot, you harden it. That's one of the ways that they do metal hardening. They'll actually heat it to harden up the surface. If the rotor got so hot that it discolored, like bluish, especially if it leaves dark blue spots, like periodic spots, those are hot spots. But if you go to put it on the lathe and you start cutting it, you're probably going to find the rotor is going to cut the nice silver spots. And then when it hits those blue spots, it's not really going to cut in that much. It's going to basically ride out and then drop back in. You're going to find their hardened spots, and they're going to be high by the time you're done on the lathe. They'll look kind of decent before you cut them. And then after you cut them, they will be an absolute nightmare. And then you'll have to do the walk of shame and say, oh, I can't actually cut these. We need to replace them. And they say, well, why'd you have me sell them? You should have told me to sell them the first time, not tell me that we could cut them and then come back and tell me we can't. Right. So look with your eyes, look carefully. You'll know if you see them. If we find some hotspot rotors, we'll take a picture and put it on the group chat. I don't have any right now. Or if it's cracked, it's a no-go. So make sure you're looking for defects. And then do the measurements, do the resurfacing and do the measurements, measure the runout, etc. All the stuff that we've kind of already done. And then for rotor removal and replacement, they can vary. So let's go through the steps. This you can see the knuckle really well. Right here, we've pulled the caliper already, and we just pulled the caliper bracket bolts, and now the bracket's coming out. And then depending on the style, we may actually just need to smack the rotor and it comes off. But what's actually recommended is to make a mark. Who thinks they know why we're making a mark? What if this rotor was cut on the on-car lathe and underneath it, there's a problem between the rotor and the hub? If there was an issue, the on-car lathe would have basically compensated for the issue. But if you pull the rotor off and you put it on in a different spot, now you've doubled the issue. You not only re-expose the issue, you'd make the issue even worse. And so it's not real likely, but it's a better practice to actually mark it and then pull it and then put it back where your mark was in case there is some defect. Now, and it's so unlikely, but just follow. Now, if you're going to pull the rotor off and, replace it with a new rotor, there's nothing to mark, you see? So like, this is a little bit of a best practice, but probably not super critical. It's like a 1 in 1,000. 1 in 1,000 times it bites you. So technically it's possible though. Probably not even that. And then has anybody ever used one of these? It's a impact driver, especially if you're going to work with your Phillips screw style, especially like a Honda, you definitely would want to get the impact driver. Like I have my impact driver actually right here, but you don't have to get necessarily a really high-end one. This one's pretty nice though. You could get a little bit of a cheaper one. We have one at the school. It's in the wall box 9. And then, for example, like here's the bit that I would use right there. That to me is a must-have if you're going to do brake work. You can try with the screwdriver. You'll probably strip them out. Then you'll strip them out some more. And then you go to get the impact driver, and the impact driver won't work because you already stripped it out so bad with the screwdriver. And that's why I said, just go for the impact driver. Right. And then remove some of the rust. And then here it's talking about, getting it cleaned up. If this was the wheel bearing type, the hub rotor type, you actually have to remove a cover, remove a cotter pin and a locking mechanism, and then actually take off the nut, the washer, and then see this bearing's about to fall out. Get that bearing out. And then you can mostly pull the rotor, but what was done right here is a little trick. We actually pull the outer bearing and then we restart the nut. And then when you go to pull the rotor off, you kind of pull it downward and the nut catches the inside edge of the bearing. In the inboard bearing, there's 2 bearings. There's the outboard bearing and the inboard bearing. The nut actually catches the edge and it yanks the bearing out the backside. So now your rotor's got no bearings in it. It's a little easier to do it this way. But then you'd get your new rotor. You might have to clean up the hub. So this is an example of clean up the hub. It's a little annoying because it bounces back and forth from hubbed rotors to hubless rotors. But if you're a hubless rotor, you're going to have to clean that hub up. We did that. Oh, that's right. I did that discussion video. Very good. Right. And then the new rotor is getting slipped on. Look at our marks are lined up. Cool. Now you know why. Putting those screws back in. Anybody know why those screws are there in the first place? Well, I'll help you out. The screws are only there for when they're assembling the vehicle on the assembly line. The wheels aren't on it yet. So that car may be getting tipped sideways and upside down. They basically just hold it on while it's on the assembly line. Once it's off the assembly line, think about it. You have 4 lug nuts right there, torqued to 76 foot-pounds or something. that little screw's not doing nothing. It's got a whole wheel holding it on and lug nuts. So that's the real reason why you could, yeah, it's nice to put them on, but basically I'm telling you, yes, you don't need to reinstall it. Correct. Now, Toyota doesn't generally do those. What they'll do is they'll do a little steel, like they'll call it a Tinnerman nut. And that's like this little steel these little steel clip thing. That's again, just to make sure the rotor doesn't fall off. When you pull a wheel off and you see that Tinnerman nut, which tell you what, I'll even show you one because I really do want you to see that. Something I should add. See, the problem is I can't see all my tabs up here. So it's big screen. I have no idea why that's up. Tinnerman, you should follow Rigo Ratio. You're gonna meet him. He's gonna teach transmissions for you one day. All right, check this out. Here is a Tinnerman nut. Same for drum brakes. Yep. Let me see if I can do an images. Let's see if we can find one on the car. Tinnerman nut on a rotor. Bingo. Check that out. See how that Tinnerman nut's on there? That's, again, just literally for the assembly line. If I was going to take that rotor off, I'd grab the side cutters, cut it, grab the other side, rip it off, throw it in the trash, never look at it again. You understand me? Never look at it again. If I see you put one of those things back on, I'm going to disown you. I'm going to tell them, never knew you. Who? Never knew. So throw those in the trash. Those are garbage. Now the screws, honestly, I still put the screws back in because it does hold the rotor pretty nice, but it's actually really not necessary. Okay. It's just not. Right. And then you could see put it on clean. And then there was the discussion on how to set the taper for those wheel bearings. Just do not make the mistake of thinking because that nut is big that you run it in with a gun. You run it in with the gun, those bearings are going to be so tight. They're going to make so much heat. They're going to seize to the race. They're going to totally ruin that thing. It's going to be a mess. Cool. And then this gets into wheel studs, but you know, wheel studs is going to be its own video, but basically like this would be a good time to do wheel studs as an activity. So we will, you could draw them in, you could use a press, you could probably hammer them, etc. And then as we're about to be finished, you know, it's very important you understand what the engineers say. I don't know that I have the facts. I'm going to tell you straight up. The engineers say if you picture a 5-lug wheel and you install the wheel and then you blast all 5 of the lug nuts, the explanation is those lugs are drawing in really hard. And when your rotor gets hot, they're tending to try to deform it, kind of giving it like some runout. So over torqued lug nuts allegedly can lead toward more brake pulsations. And, you know, to be very honest with you, I'm not really the person to be able to say that's true or not true. I got to tell you, I have some, a little bit of like, you know, I tend to not just believe everything I hear anyway. So I'm kind of like, I don't know about that, but that's what the engineers say. So I'm telling you, part of the reason that we torque the lug nuts to spec is to make sure that we're not causing unnecessary rotor warpage. That's our fault. Okay. For what it is. Maybe true, maybe not true. But at a minimum, we're going to make sure that we do the torque sequence and the torque specs and everything is going to be legit because that's the correct way to put the wheel back on. Right. But some of that stemmed from the reason we don't blast them with the gun is it might lead to warping. Blasting them with a gun, if you really blast them, that can and will lead to metal fatigue on the studs and on the nuts. And you're probably going to need to replace your studs and lug nuts more frequently. So that is a thing. If you under tighten it and it loosens up, the wheel falls off. So, you gotta get it there into the range. If the spec is 76 foot-pounds and you're at 80, great. Even if you're at 90, still pretty good. If you're at 100, like, all right, back off there though. Right in that range is gonna be fine. If you go with your new cordless impact and you send it, I bet you those will be at 160, 170, 180. That's a little different. That's like pretty excessive. So I don't go real crazy on the wheels being torqued real specifically. If it's a head gasket, if it's a crankshaft main bearing or something, yeah, we're gonna get really serious. On the wheels, just get them torqued, okay? Now it talks about the lug pattern, and that's why it also says, at least to get it threaded up as much as possible by hand. Well, Daniel made a pretty good point in the chat. If I want to run lug nuts up with a gun and not put a torque wrench on it, that's on me. And I can do that, by the way. I mean, basically, you can do anything you want. There's just going to be a price to be paid. Okay, so if you want to blast them with the gun, blah, 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 I've done it. Okay, I've done it. But if something goes wrong, I'm not going to tell you it's not my fault. I will own I screwed up. I will say, you know what? I knew I was supposed to follow TIS. I knew I was supposed to follow service information. I knew I was supposed to torque it to a specific spec, and I didn't do it, which means I'm guilty. So hopefully whatever went wrong is not a big deal, because if it is a big deal, I'm guilty and I just said so. So you got to think about that. At the end of the day, though, I sleep pretty good because I know whatever screw ups I have, I own it. And if I'm usually taking a risk, it's very calculated. I'm pretty sure I'm not going to have any problems. Okay, true story. And then after we do the job, there's actually a burnishing process. So that's something that I'd like to say, they'll call it bed in or burnishing. Basically what you're going to do, you're going to have all your new brake pads and your rotors resurfaced, or new rotors or whatever, and they're all going to be cleaned in the parts washer or brake clean and stuff, and lubed and all that. But then you're going to go drive it, and you're actually going to get up to a reasonable speed and apply moderate brake pressure, and you're going to stop. Get up, and then you're going to drive for a little while so the rotor's cool, and then you're going to slow down again with moderate pressure, and then give it a while so it cools off. You're going to do that several times, and the number of times can vary. So sometimes, like Toyota will specify it, and other times, let's say you bought brake pads from Wagner may specify it. So who's specifying it can vary. Tesla, for example, had a really cool one where you put it in burnish brake pads mode, and it will tell you how many times to do it and how hard to stop. And you have to get your brake pressure in this little range. It was pretty neat. I think they took it away. But that's basically the break-in or the bed-in procedure. We do that. The customer doesn't do that. We do that because when we do that, we have to do it right. And when we do it, they're probably going to smoke and they're probably going to stink. And if the customer sees smoke, I'm telling you right now, they're coming back. Now, why is there smoke? Well, we probably have a little tiny bit of oil on the rotor or the pad, right? Even just the oil from our fingers could leave a slight oil residue. So we want to be very, very neat doing this work. And then we still have to take it out and burnish them and get all that smoking stuff all gone, probably 5 miles later. Then we can park it. Then you give it to the customer, and the customer's like, oh, my brakes are great. The customer does not see the smoking. You don't let the customer see the smoking. Okay. And then lug tightening kind of talks about this. This is Toyota specific, so it's saying no. It's saying why. And it even gives you some different vehicles. So pretty good to know. And then we're gonna cover machining. So machining is gonna be its own subject. Okay. So you guys will be ready for the lecture quiz. Okay, so the question was, why did the brake pedal go to the floor at the dealer when it crunched somebody? So check it out. Here's the rotor. Here are the pads. Okay, so you guys can see, I'm gonna bring them up here. See how the pads are touching, right? When we do the brake job and we push the piston back, there's gonna end up a gap. So you see the gap? The first time you hit the brake pedal, you know what it does? It brings them closer. So the first time it didn't stop anything. It just, they were pushed back all the way and then it brings them closer. So then it'll actually engage and slow it down. So that very first time, you got to jump in, you got to pump it again, maybe pump it a few times, and then they'll set, then you'll get a hard pedal. That's when you know it's actually ready to move the car. Don't move it before then. Kind of make sense?
Yeah, gotcha.
So the question is basically, what's the difference between runout and parallelism? I'll show you. If I get that one. Yeah, I should have put it back. Okay. Rotor runout would be dial indicator right here, and the rotor moves like this. See, so the rotor might not vary in thickness. It just means it's not spinning true. If you think about what that's going to cause, that's going to actually cause the wheel to shake like this. So according to the books, that would give you a steering wheel shimmy like this, like that. However, parallelism is different. Parallelism is where we're thick, thin, thick, thin. If you think about that, when you hit the brakes, now your brake pad is going to be, your brake, picture a 4-piston caliper. Your pistons are going to be going like this. Thin, thick, thin, thick, thin, thick. That's going to actually pulse the fluid, which would pulse the pedal. So that's basically the logic. The logic would be if it's just run out, the piston should be able to follow it. The piston's not going to pulse. The caliper is actually just going to follow it because it's just run out. Whereas its thickness variation, it's going to actually cause a pulsation in the fluid. So if you wanted to do the by the book answer, it would be thickness variation or parallelism would cause pulsation in the pedal, and run out would cause shimmy, which just means shaking in the steering wheel. But to be really honest, the ASE will never ask you to separate those two, because the way that ASE questions are written, there's a panel of people. And if I was in the room, for example, and they were to say, well, parallelism or thickness variation makes a pedal pulsation and run out makes a steering wheel shimmy or vibration, I would say no, because I've had cars that don't follow that rule. I've had numerous cars. My general rule of thumb is if the steering wheel shakes, it's probably the front brakes. And if your butt shakes, it's probably the rear brakes. But if you really want to know, you measure it. So right there, the ASE would have shot that question down. So if you don't totally understand, that's fine. As long as you understand what I just said right there, you're more than good.
Kelly, will you demo how you want us to take off? How you were saying how during the slide you're saying this is not how I would do it, but this is like I'm gonna tell you how. Yeah, you're gonna okay, cool.
Tomorrow is the way I would do it. It doesn't mean you have to do it my way, but in fact, this is a good time to give you the argument. So the by the book way, you go to do the brakes, you loosen the bleeder, you push the piston back, the brake fluid comes out. It goes right on the ground, bleh, just like that. Cool. Now when you're done with the brake pads, when you're done with the brake job, what do you need to do? You need to go get fluid. You need to add fluid. But you know about brake fluid. You can't just add fluid that's been sitting around on the shelf. So now you need to go get actual sealed brake fluid, which costs money, and add it. And you need to bleed the brakes, and you could probably bleed the brakes pretty quick, gravity bleed, maybe, I just don't, I'm not in love with the vacuum bleeding, but you could probably knock it out pretty quick. But what you just did there is you made your brake job take longer than everyone else's and cost more money than everyone else's. So if everyone in your shop, let's say your shop's got 20 people, if 19 of them, the brake jobs cost this much, and then your brake jobs cost another $11 because the brake fluid, it's gonna be like, seriously, we have to give special pricing because the way you do it. So from a pure standpoint, that there's nothing wrong with doing it that way. From a practicality standpoint, I would say it's less efficient and it's wasteful of the customer's money and time. Now, from a technical standpoint, someone may say, yeah, but you press the piston in and the dirty brake fluid goes out, rather than you compress the piston with the bleeder closed and now you've pushed the dirty brake fluid up and potentially into the ABS unit. And I'd go with that actually. It's hard for me to argue that. But this is what I would say. If there's something wrong with the brake fluid, then we should be selling a brake fluid service, a brake flush. Why am I going to just drain a little bit of it to avoid going in the ABS unit? If there's something wrong with the brake fluid, let's do the brake service and the brake flush. And the evidence to the customer would be, you have dirty brake fluid, and we can test it X, Y, and Z. See what I'm saying? So I'm still not going to do it that way. The other thing is, I can tell you from firsthand experience, I never brag about the level of experience I have because there's always someone with more. But they'll brag about it, and there's probably always someone with more for them. So I don't know. There's always a bigger fish, you know what I'm saying? So in the however many hundreds and hundreds of brake jobs I've done, I've always left the bleeder closed. I've always pushed the piston back. I've had absolutely zero in any way ever whatsoever problems with the dirty brake fluid being pushed back into the ABS unit. It seemed to me like a lot of older school technicians were good with doing it that way. And then the ABS unit came out and they're sort of like, oh, we don't want to push dirty brake fluid into that. And they, it just seems like it's an erroneous fear, meaning like you're afraid of something happening that's never actually happened as far as I know. So I'm leaving that bleeder closed. I'm saving the time. I'm not billing the brake fluid out, and I'm going to still be, I'm still not going to have an issue. So I see no reason at all to do it the other way. Now, let's say that you want to do it the other way and you've got your reasons to do it the other way. I'm in no position to tell you it's wrong. I'm not in any way saying there's anything wrong with opening the bleeder. I'm not the one who'd even take issue with it. The person who has to bill the customer may take issue with it, or the customer themselves may take issue with it, or you never know, the customer themselves may be like, you're the best. But I'm not going to do it that way. So that's the long reason.